welcome you all to this new video today. Today we are going to see on the topic production technology. Okay, so welcome to my new video here. This is Michael Jones, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. So for production technology, I hope you have seen my earlier lectures on the differences, the classifications between production and manufacturing. So in production technology, we are moving to the topic metal forming and powder metallurgy. So in metal forming, what is metal forming? Where do we use all these processes in the modern metallurgical engineering? We are going to see. So first of all, the introduction to metal forming and powder metallurgy. So the introduction here is given as the metal forming encompasses various manufacturing techniques that reshapes metals through plastic deformation. So we are going to create and deformation that cannot be brought back. So it is an irreversible process. So that is metal forming. We are changing the regular form of an object of a metal. Then powder metallurgy, it involves creating metal components from fine metallic powders through compaction and sintering. So what is compaction and sintering? It is that we are going to we are going to compact fine particles of a metal powder into the required shape. And sintering is a process where we'll use a laser or we'll use a resin such that we'll localize a particular area or particular section of the part for it to be hardened. So this is a metal forming process and powder metallurgical integration in metal forming. Then what is extrusion? Extrusion is a metal forming principle where a bulk metal is extruded. It is being pulled or pushed through a smaller cross-sectional area. You can see the extrusion machine on the left-hand side. So we'll be having a permanent die. So through the permanent die, a regular shape will be made in the permanent die, and the molten material or the metal that is heated to the recrystallization temperature will be pulled or pushed into the required shaped die under very high pressure. So it is the core principle where we have a very key advantage that it creates continuous length with consistent cross-sectional geometry. Single cross-sectional geometry will be uniformly maintained in this extrusion process. Then the impact for manufacturing is that it is essential in producing components that ranges from smaller to larger in a precision parts. Then the principle of extrusion is given here. So in the principle of extrusion, we are going to follow 4 steps. That is a billet preparation, then the flow application, then material flow, and a product is formed. So in this process, it is just if I can imagine this process that billet is that the raw material is simple let it be for example it may be plastics. So plastic billets, for example in an aluminum extrusion we'll be using aluminum billets, we'll be using the metal billets. So these metal billets will be placed in a hopper where these metal billets will be forced into a section. It will be forced into an hot chamber where the compressive force and temperature will be applied to these metal billets. When the metal billets are in a temperature to flow, then the die opening will be opened and the extrusion will be happening to produce the form. The extrusion process we have 4 different types: hot extrusion, cold extrusion, direct extrusion, and indirect extrusion. So in hot extrusion, material is heated above the recrystallization temperature, and in cold extrusion, the material is extruded in the room temperature or very slightly elevated temperatures. Direct extrusion, it is that billet and the ram moves in the same direction. Billet is that the raw material, okay, the raw material and the ram will be moving in the same direction. In indirect extrusion, it is very common that opposite of direct extrusion, the billet and the ram will be in an opposite direction. That is, for example, we'll be using a hollow ram. So when the ram is pushed into the piston, then material will be flowed out through the hollow section. Then extrusion equipment and tooling. So in extrusion equipment and tooling, we'll be having a container, a ram, an extrusion die, and the press or the frame or the structure. So in the container, we'll be having the billet. And then the ram is the plunger that is going to apply the force. Extrusion die is the die that is going to cause the required shape. Okay, only through the extrusion die we'll be having the required shape. Then the structural or a frame is the entire supporting structure that is going to have this fixture. The steps in extrusion process already we saw. So the first step is to billet preparation. The second is heating the billet. Third is applying lubrication. So this lubrication is provided to reduce the friction between the billet and the container. The fourth is the extrusion operation, and the fifth is a cooling and finishing operation, where the extruded product that is in a slightly elevated temperature will be cooled down to the room temperature. So advantages of extrusion is given here. We are going to have a material efficiency and complex geometries, superior properties, and continuous production. So material efficiency is that we'll be having lesser wastage or the scrap material production. Complex geometries, the geometries that cannot be done through machining can be done using a extrusion process. Superior properties is that the grain size will be refined to very smaller extent, such that we will be having a superior strength, and the continuous production, high long strength structures can be done. Disadvantages is high tooling cost. We have to prepare a die. The material limitation, certain materials will have the reduced efficiency to flow. Size constraint, very small dimensions can be used. Larger dimensions will not have that accuracy. Dimensional variations, some cases we'll be having little tolerance limits. So the applications and importance in modern manufacturing is construction sector, automotive sector, piping and tubing sector, electrical applications. All these areas we are going to use the extruded components. So for example, I have given listed out here. In construction industry, windows, frames, profiles can be made. Automotive sectors, the heat exchangers can be made. Piping and tubing, electrical applications, the heat sinks can be done using this extrusion process. So we have seen the extrusion process as a part of metal forming industries. So extrusion is the one such type for metal forming structures. I hope you will be having a good idea on this. So thank you, and we'll see you in the next video.